CSOMIO project is going to try to synthesize a lot of the knowledge that we've learned from previously funded GoMRI projects. And we felt like we came to a point where we had a lot of the pieces put together, but we've never put all the pieces together in one place and sort of ran oil through the entire system. And so we decided we would try to do that with using numerical simulations, testing some of the things in the laboratory. But this is mainly a numerical project. And the idea would be that we could build a tool that you could use for future spills. The novel focus on this project is on sediment oil interactions and microbial oil interactions. Well, I think there's a big question about what the fate of oil is. So there are lots of questions about, even just at the wellhead, what's the droplet size distribution? How does that droplet size distribution change over time as it goes through the plume? And that, in turn, will affect how effectively microbes can eat the oil. It'll determine the rise rate or the sink rate. Right. The interaction with sediments can change that sort of physical process of breaking the oil up fundamentally. So oil will rise, but the sediment, and when it interacts with sediments, it can start to sink with the sediments. And again, when we break the oil up into small droplets, the microbes have to be present. The right communities need to be present to take advantage of that, to use that as food. Most organisms don't like to eat oil. But there are some that do, and they live in the Gulf, and we believe that they are there because the Gulf has a lot of natural seeps, and so there are microbial communities that have evolved to use that as a food source. Well, our ideal would be to create a modeling system that people could run right away when a spill occurs that would help us predict where the oil would go. How much would stay subsurface? Where does the surface oil go? How is that affected by wind, waves, currents, sunlight, other sediment interactions with the Mississippi River plume, things like that. That'll give us a much better handle on where to focus response efforts if we can predict some of the basics like that. I think that hopefully our modeling system will also be used just in basic science, taking pieces out and using them for particular studies. Well, in terms of the project, I think I'd like to just say that this is one of the most unusual projects that I've been involved in a good way. It seems very creative. I think that we've put together a lot of elements that usually don't come together. And for example, one of my favorite aspects of this project will be that we will create a biological ecosystem model with a number of constituents. And so each constituent will represent a plankton or a bacterium or something like that. And they won't represent real organisms. They'll be created by giving them various traits, and then they'll be allowed to evolve. So we can see, we might not know exactly what organism is where, but we'll be able to see what place in the ecosystem organisms like to evolve to. And that will help us understand a little bit about the community structure, say before a spill and after a spill. If we understand how the microbes that evolved to like to eat oil, where are they in the Gulf? And I think that's a really novel idea that could be, in this instance, very effective in answering some of the scientific questions.